Welcome to another 3D comparison video. This will be the case study. I have over here one model made using orthographic renders, one over here using perspective, and this will be the original model. So let's take a look how I originally generated those images, starting with this within Keyshot. And after that, we're going to transition to Generative AI, the models created by Rodin using the perspective and the orthographic views. This will be the case study car, and we see over here the lens with perspective will look like this. If I'm going to swap this to orthographic, we're going to see that the overall car will look like this. So the main purpose is to see over here if we should use perspective images or we should go with orthographic in this case. So I already created over here various views. For example, the front view using perspective was rendered like this. I also disabled the shadows in this case because I only want the model. And I did the same over here also for the orthographic. So for each view, I have those already prepared. So we see them over here, front perspective. We're going to have over here orthographic front. And I did the same for the back, for the side, and also for the top. Now, those were then inputted within Rodin, and we're going to see exactly over here what will be the output for this. So as you can see, they are still being processed over here, and I still need to align the direction of each view over here. But let's go ahead and check by default what Rodin managed to output. So this is the first one, as you can see over here, and this will be the second one. We're going to see over here also those changes. Now I didn't specify which view is which, and we see that Rodin managed to align all of this quite well. So I'm going to go ahead over here and I will start with the first one. We're going to see that in this case, let me just take a look at the images. This will be the one which will be, I think, the orthographic. So we see it over here. It's like that. So let me just check the reference. It's actually this one, so the orthographic. And the second model will use the perspective, so we can see it over here. Now, let's go ahead and align this. So in this case, this will be the back view. To do so within Rodin, we can see that it's quite easy. This will be the left view. So this, I'm going to align like that. This will be the front. So we have the back, we have the front. This will be, in this case, the right view. And this will be the top view, which in this case, it will be the following. So it will be called up. Now I'm going to go ahead and I will have this redo since I have those aligned. And I will do the same over here for those that will be in perspective. So this will be the back view. This will be the front view. This will be the left. This will be the right. And over here as well, we're going to have the one from the top, which will be called up. And again, I will send this in order to have that reprocessed. Now, once this model will be finished, I'm going to import this within a CAD solution, and I will do some deviation comparison between those because I want to see in millimeters how large are those difference between the input model and the one made using perspective renderings over here and the one made using those set within orthographic. Because we can already see that the overall shape of the car is a little bit different within these two previews. So this is the one with perspective. This is the one with orthographic. And there are some slight changes. For example, take a look over here at this headlight. It's completely different. Okay, so this looks to be aligned. So I can go ahead and I will confirm that I want to create this. I will also use the models made with triangles because they will have much more detail than the ones made with quads. So in this case, I'm going to go for triangle. I'm going to hit confirm. And I will do the same over here. This is still being processed. It should now update the final version for this. And again, with triangles, I'm going to hit confirm. In this case, the texture will not be important since I use those renders where I had the car set as gray within keyshot, as you can see it over here. So that will not be important. Now I'm waiting for the final model to be finished. And after that, I'm going to load this within a CAD solution. I'm going to prepare the deviation analysis, and we're going to see exactly which will be the best output in this case. Okay, so I have the models over here ready. In order to define the deviation analysis, I'm going to use CATIA v5. And in this case, I already went and have these files downloaded as STL files. So I've chosen this because I don't need the texture in this case. And I already have them over here downloaded. Now within Blender, this is the original car model that was also rendered. I'm just gonna remove the material over here. So I will make use of the following script over here in order to do so. And we have the same car model that was added within Keyshot in order to obtain those renderings. Also within Blender, if I'm going to press 5 on the numpad, this will swap between orthographic, as you can see, and this will be the orthographic view. If I'm going to press 5 again, this will change the camera to be perspective. Now let's open those models from Rodin. So I'm going to go to import. This should be within STL file. You're going to see them over here. So they will be roughly the same size. And when I import them, I'm going to see that they will be a lot smaller. There are some difference between those two. So we already see some changes between the orthographic. I have a misspell over here for orthographic, as you can see. And the other one, but with those two selected, I'm going to press S and I will scale them in order to be close to this reference. So as you can see, it will be a little bit harder to make them exactly the same. So I'm just going to separate those. So I'm going to bring, I see that the perspective one hasn't been scaled yet. I'm going to roughly scale it until it will go ahead and match that overall shape. I'm just going to create a material over here and I will make this a different color so that it will be a little bit easier for me to overlap and see exactly what scale I should have this set. I already see over here that there are some slight differences and I don't want to scale this only on one axis because in this case we see that I should actually press S and on the Y I can further extend it to make it close to the reference, but the main purpose is to not to interfere with that. So I'm only gonna do uniform scaling on all axes. So maybe it should be somewhere a little bit closer to this shape over here. Now I'm going to move this over here to the sides or I will hide it. And I will do the same over here with this one. I'm just going to make the material different. And I will go ahead and I will overlap this. If I'm going to press 7, this will give me the top. And I'm going to press X in order to only move it over here. And I see that this is slightly smaller, so I'm going to scale it. In this case, we're going to see that the mirrors will be slightly offsetted. The one with red, we have it over here. So this I didn't actually fit and align it onto the middle. I can also use the line tools over here within Blender. So currently I don't have those enabled, but I can go over here. I can search for a line for extensions. Let's see, align toolkit, align tools. So this will be, I'm gonna hit install. And let's see now with that align tool, they should appear over here. So within item, we're going to have the following align tool. If I will just move this to the side, we're going to see the origin of the geometry will be over there. I'm going to move this over here as well. We see over here the scaling factor was a little bit different while I scale those. The dimensions over here will be 216 for the X, in this case for this one. So over here the mesh is not fully joined together. I can go ahead, I can right click and I can join those two. And now we're going to see the dimensions. So The car should have 4 meters 66 on X. We see over here that for this dimension will be over here on Y. So I can go ahead and I can scale this a little bit more until I reach the same size. Because we see over here that this is slightly smaller. So I'm just gonna press S and I will slightly make this bigger until I will reach the same value. Even though we see over here this will be on X and this will have that on the Y, but actually this will be the length. So a little bit smaller in this case, somewhere like this. Now, if I'm gonna overlap it, it should be close to those proportions because it has the same length. Over here as well, I'm gonna slightly scale this. So this is the tricky part regarding generative AI, is that it's not actually gonna create things at true scale. And now we can have this aligned. So we can use this align tool. We see over here, we also have align scale that will just scale it. So I could also use that, but I'm interested within location over here because I already scaled those manually. So I'm going to select these two and we're going to align the location over here on X, on Y, and on Z. I will not do that because as you can see, the reference for this mesh is somewhere over there. So I should also change that to be within the geometry. So for all models, I'm going to move that point to be in the middle of the geometry. Origin of the geometry. And now let's see that alignment on all axes. This is what the align tool considers to be the alignment on all axes. So I'm not sure exactly if this is that perfectly defined, but let me just go over here to the front, to the right view. There are obvious distance changes over here. As you can see over here, the distance between those wheels for this model, which is the orthographic one, the original one, which is the following, and this one. Overall, we see that this car, the perspective one, will not be so long over here on the front of the car, as we can see. So those are the changes that the meshes will have. And I can go ahead and I can slightly, maybe manually align them a little bit better before I'm going to do that comparison. But there are some visible changes over here, as we can see. So maybe something like this will be a good match. And I can go ahead and I can, let's say, I will call this the reference. I'm going to have this additional model, which is the car paint. So I can actually export this. So I'm going to go ahead, hit export, STL. I'm going to call this selection only to be included and exported reference. Export. I'm going to go for the orthographic one, file, export, same STL. This will not be the reference, this will be the ortho. And I will still have the perspective one to have that exported file, STL, exported perspective. Okay, so we have those file defined. We see that there are visible changes over here, for example, the front of the car, that wheel distance, but let's see exactly within millimeters how much are those deviations. So I'm going to go over here within CATIA, within Digital Shape Editor, and I'm going to import those. So I'm going to hit over here import. We see over here the scale factor. This will be set to 1000. And in this case, since I'm transporting those from Blender, which has meter as the default unit, I'm going to go over here, so exported reference. I'm going to hit apply. And I'm just going to check the overall size for this. So we're going to see that in this case, this will have the correct length. So 4 meter 4.6 in this case. And I know that the settings over here are set correctly with file unit millimeter, scale factor 1000, since This will convert the file from Blender, which is meters, over here to millimeters. And I want also those two additional export to be added. So I'm going to hit apply, and we should have those over here. So I also had that check in order to replace. So I'm just going to go ahead and I will select all those files, all three with exported. This is the replace button that will just replace everything. So I'm just going to bring in all three files. So this is the export reference. This should have the name import. It's a little bit trickier. I'm just going to go ahead and I will import those one by one. So we have the reference. I'm just going to remove that. This is the reference. As you can see, export reference. I'm going to bring in the following one, which will be the orthographic view. I will not have that replace checked. This will be the ortho. So it's a little bit better to do it like this. And this will be the perspective. And now we can define that deviation analysis. If I'm going to go over here onto deviation analysis, I'm going to have the reference, which will be exported reference. I want to measure the ortho over here, the ortho model. And I can leave the default over here, so I can just hit apply. And we're now going to see that deviation in the color map applied to the model. It will take maybe a little bit of time, but yeah, we see over here that this currently will display the max value. So we have a positive max value over here, which will be quite high. We see that in millimeters over here. Not sure exactly why it's that high, because it is really high. I'm gonna go over here for points. And we're gonna see the average deviation where I'm gonna keep my mouse on top of the model. So if I'm just gonna move it over here to the wheel, we're gonna see over here that deviation. Over here, we're gonna have 53 on the yellow area. I can also check over here the spikes. I can also enable the texture. And this will make it visually a little bit easier to check, because we have those. So this is between, I'm just gonna hide the perspective one like this. And we see over here those changes within the mirrors. So this is slightly offsetted by quite a lot, by around 10 centimeters. We're gonna see over here in front that will be roughly, let's say, 12 millimeters, and those max points will be, in this case, 13 centimeters in this case. So quite a lot of deviations, but let's just check the negative maximum and the positive values. So they are roughly around 13 centimeters. So let's go ahead and create the second deviation analysis between the reference and the one which will be the perspective one. And I'm just gonna check all of those, initially with textures, and I'm gonna go to the max points after that. But we can already see those differences over here as well within the mirrors. So I'm just gonna check this. So in this case over here for the wheel, we're gonna have actually a larger value. If I will go for the max value, we're gonna see that it will be a lot higher. So minus 17 centimeters over here. So, and over here for the wheel, we're gonna have a huge difference in this case. Also, we see that the wheel line is not that well aligned in this case. So maybe I could have manually aligned those a little bit better over here and scale them. But I went for that value in order to have that matched. If I'm just gonna go with points, again, we're gonna see that this will be the following. But the main conclusion in this case is that the model made with perspective will be slightly with larger deviations than the other one. If I will enable over here the compass, and I want to drag this, and I want to drag also the exported perspective, I'm going to move that to the side. We're going to see that Katia will take a little bit of time to move it, since we also have that deviation analysis added on top of it, and this is an STL. We see that I slightly moved this around 3 meters. Within Blender, it will be a lot easier to just move those to the sides. But again, it was a little bit trickier over here to exactly see those differences in millimeters or centimeters in this case between those models. But overall, I know that using those orthographic images will give you a much better model than when you are using the ones using perspective. So this is something quite interesting. We see over here Katia will still struggle a little bit to move this. It should finish, but overall we already draw the conclusion in this case. So overall, obtaining that model using the views made with ortho are a little bit, let's say, closer to the reality of the model than the one made using perspective. Okay, so I hope you enjoyed this kind of content. I'm going to position a similar case study over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.